So, STC, Sensible Things That Communicate, is now a research center at Mittuniversitetet. Used to be a project, now a research center, with a focus on sensor systems and sensor services, focusing industrial IT. And the challenges that we address is that we should perform excellent research. At the same time, we should produce competence to our partners, companies in the region, nationally and internationally. But we should also some kind of creating growth in existing companies, which is often a requirement when we do projects in KK Foundation, Vinnova, etc. But I would say later years, it has also been a requirement that we should create new companies. And that's the theme for today. How can we create innovation from research, and in our case, sensor-based research? To do this, we are in a context, a regional context, and a nationally. Closest to the researcher, we have Mittuniversitetet, which is the university pre-incubator, which helps us researchers to get our ideas out and to evaluate the potential of them. Apart from this, there are external nodes. We have Fiber Optic Valley, which is an innovation cluster. We have Åkroken Science Park, which is a business incubator, Venture Cup, and a lot of other actors that want the researcher to succeed, producing growth from our research, both to existing companies, but also perhaps to create new companies. We have this ambition for quite some while in STC. There are some already created companies, Sensible Solutions, SEPS, Midect, Erbium, Radium. And the one that we'll talk about now, which is on its way out from the university. There are other initiatives which are in the pipeline at Mittuniversitetet. And the question is, who will get lift off first, if any, or if it's any other. So today, the agenda is, I will start with the little story on innovation from some of my projects. Then Hans Martin from Sensar will give some inspiration to how innovation can be created. Bengt Olof, another perspective on how we as researchers can perhaps get some help in this way. Jonas Wallberg from the Vinnova perspective in this. Bengt Öhlman will also talk about how we can integrate students in this process. And then we will have some panel discussion led by Mittuniversitetet to see, is there obstacles? What can we do better? Apart from this, there is a lunch, a bit longer lunch, so you have time to mingle with the researchers at the posters and demonstrations. After the panel discussion, there will be time also to look at the posters, demonstrations, and in the evening there's a get-together with dinner and some entertainment. So, I've named this The Reluctant Innovator. So it's the story of a business idea or innovation called on top, and it's so far of this story. And I will try to see how we got this idea. This is an initiative from the industry from the start. How this became a research project and then became some innovation that we need to handle. And it also led to new research. To see what kind of experience we gained from this. I think more of this will also be discussed in the panel debate. But also see what are the financing instruments and instruments to help us in this. So this started on an initiative from Fiber Optic Valley. It started with a meeting which were not that successful. It was Iggesund Paperboard that had signed up to be a partner in Fiber Optic Valley, and the initiative was, what kind of problems do you have at Iggesund Paperboard that can be solved by fiber optics? These guys got quite confused. They got fibers, but they make papers out of it, but fiber optics? They didn't know what to do with that. So it was redone. So in the next meeting, I was also invited as a sidekick. And then the question was, what do you want to improve? And the guys at Iggesund really did a thorough analysis on all parts in the process. What could we improve if it was possible? And this was really good exercise, because then different researchers, people from Fiber Optic Valley could go through this list with the people. And in this process, I met this guy, Johan Lindgren, which is the head of development at Iggesund Paperboard. And he described a problem that I said, this we can work on. The problem is that, to illustrate it, if you put an A4 paper like this, and you put another one next day, and if we would put this, and this would be the first paper they tested on one row when they produced paper at Iggesund. And if we put them next to each other and continue until the next paper that they test for quality, the surface topography quality measured like that. Now, Zlatan is not in Milan anymore. So we need to change the sales pitch. But this is the distance of paper that would be produced untested, as they do it today. They do this manually. They have 2 people employed doing this. So they wanted to improve this, and they had tried this for several years, but didn't succeed. So what they wanted basically is that this paper line should be much, much shorter. And they wanted these measurements in real time, such that they can also control their process doing this. So we initiated a project. We got funded by the Cake Foundation. And the question was basically, is this possible? Because the paper is moving quite fast. The topography is measured in fractions of micrometer. So it's a challenging problem. These were the guys that started the project. And these were the, apart from Iggesund, we also teamed up with SCA, which also hadn't thought about it as much as Iggesund, but they realized this would be really great for our production if we could get this. In the first project, it was very research focused. innovation was not in question at all. We did simulations, we did test setups in the optical lab, and results from this pointed out that topography can be measured online. Probably. Because we've shown that this can be measured, but the industry partners, they want to see this. Does it really work in the process? Because it's a messy environment, it's vibrations in, and the other trick is that there is no standard how to measure topography on paper. It's more psychology. You need to convince the company that this is really measuring the right thing. And it should correlate to what they measure today. So we continue. We got the Project EU regional funds. The outstanding questions was, we wanted to verify this, that it really measures online, and that these measurements really correlate with lab measurements. Alain joined the team now, at this point, started his PhD studies. Then we realized to answer this question, if it can really be online, we need to go to build the thing. We can't be in the lab anymore. We need to get into the factory. So we designed this, not a very beautiful thing. And we did semi-online tests of this in the paper pilot at Iggesund, where you can take paper rolls and you can run it through this and simulate that it's a paper machine. Here it was at the setup. We also tried not only Iggesund paper, we also tried SCA paper. This is Johan from SCA. And we measured. We saw that we could get real-time values of topography. So instead of getting one measurement here and one measurement here, which could be that one is measured there and one is measured here, which gives very different values, but there is a lot of 100 meters or kilometers of paper between this, which could be of any quality. So we did extensive, or Iggesund did it for it, extensive lab measurements of this, and we start correlating this to our online measurement, and it correlates. So we, on this semi-online paper machine, we proved that this really works also at high speed. And then, I mean, the fastest paper machine runs at approximately 2,000 meters per minute. So it's quite fast. It's a bit over 100 kilometers per hour. And when the partners saw this, they wanted it. They wanted the instrument. So then we got a bit changed focus. It started to become, we needed to investigate if the innovation potential of this. So we started to outline a patent for this, and we got funding for that from Innovationsbron. So there is a patent application filed and also an EU application for this. We started to look at business verification through Venture Cup. Parts of this is also done in the Innovationsbron project. And the business development, we entered the first phase. We got 1 of 10 winners at Venture Cup North. We ended up in the second place in the North final and was in the Sweden final, where we came fourth. We all became fourth, except the first, second, and third. And this was a very good experience because we learned a lot from this in this process, how to think differently than just thinking research. So at beginning of this year, the method was verified for online measurement, or semi-online. It delivers what the customers want. We had reached this psychology barrier that they really trusted that this was what they wanted. Because we cannot correlate to a standard measurement because we need to find something to we need to show them that it really measures what they measure today. They want it now. There are some problems with that. Go into that. Alam made his licentiate the spring of this year. The uncertainties is that this is the meter, how it looks now. It's working. It's a piece of art, I would say. It's not very producible. It's built on the spot and adjusted to measure the right thing. There are also some issues on how big is the market for this. There are also outstanding research questions. We have proven that this measures online, but we need also to understand how it really works. Because measuring optical on paper it's hard to know what you really measure. Because some parts of the paper becomes transparent, but we measure and we correlate to the offline measurement. But we need also to know the limitations of this. So the continuation of this, we got a project to remove these uncertainties from Vinnova, Mittuniversitetet, and try to make a product out of this piece of art, which is producible. Verify it for industrial use, really put it for a long time in the paper machine, and verify that it really works for a month. Fine-tune the business part of this, and as it seems, Igesund is really eager to get the first one to start. They want to start their research, because now they measure offline, and they can't control their process on the most important quality parameter, the surface, what they sell their product on. So they want to investigate how can we control our process using this instrument, which they can't do before they get the actual instrument. But it also leads to new research. Investigate the limitation of the measurement method and really understand what sets the limits of this. And this is the status yesterday. I went down to Anatoly's lab, and this was what I found. And this was the state of my desk yesterday. And this should become a product in 2 weeks. But it looks quite promising. There's a lot of things coming in at the end of this week from external contractors. So, and the software is, at least the first version is quite finished. So it looks really good. So this is the actual real-time state of the project. This is a Scrum sprint backlog of the project that we use for management of this. And it should be all green, then it's finished. And it seems promising. So if we summarize this, we started with an idea that was initiated from Igesund. They wanted to improve their process, and they've tried with commercial actors. They haven't succeeded for several years. We did a purely research-oriented project, just trying to answer the question, is this possible? Which was that it probably was possible to measure this. And continue this in EU regional funds. And somewhere here, we ended up verifying that this actually works. During this time, we got extra funding for the IP handling and also some of the business verification. And the Venture Cup, quite successfully, which also prepared us, both these activities, Innovationsbron and Venture Cup, prepared us to the next phase, getting the project from Vinnova. Because when we've gone through this, we had most of the application for that. So, and this also led to new research. That Alam continues its research, investigating the limitations of this measurement method that we've developed. The plan is in this project that in 2 weeks we should have an industrial prototype that can be installed in the paper machine and deliver measurements over time, long time. And hopefully this will be moved to a company during next year. And apart from the innovation part of this, there is quite some academic publications coming out of this also. And hopefully a doctor next fall from a lab. So it includes both innovation parts and research, pure research. And it also includes a lot of the different financing parts for this process, with research-oriented, creating usefulness for existing companies, verifying the potential, creating business around this, and also verifying it, getting it to a product. So it really uses all the existing methods that are out there, almost. So the next thing we need to decide is how to move on when we get this product working. And which I leave for the panel debate is the experience. What can be learned from this, and what are the big challenges when we see it from the researcher perspective? Because this whole process also comes with some kind of drawback, that in a project like this, when you want to verify the product, you want to verify the business potential, from this activity, very little publications will come out. So that means that our productivity as researchers decrease when we do activities like this. So this is something one needs to be aware of when we talk innovation and in a research environment, that it can get too much and we decrease the productivity of the researchers. So that was my talk today.